Hello everyone. This is the video lecture for Calculus 2, section 10.2, parametric calculus. So what is parametric calculus? We'll be now taking derivatives and integrals in parametric. That's it. So let's do this thing. 10.2.003. I have x is equal to t divided by 4 plus t. And I've got a y is equal to square root of 4 plus t. And they say find dy dx. Find your first derivative. Well, it's just as easy as it looks. I'm going to find the derivative of this, find the derivative of that, divide them, and we're done. That's it. So x prime dx, whatever you want to call it here, derivative of x. Let's find the derivative. So that's, of course, going to be quotient rule. So low d high minus high d low divided by the square of what's below. Cool. We'll fix that here in a second. So what about y prime, dy, whatever you want to call it? So I got power rule, so the 1/2 comes to the front. Now it's a negative 1/2. Chain rule says derivative of the inside is a 1. And all I'm going to do is say dy dx is actually going to be this y prime over x prime, which is going to be this guy divided by that guy. And we're done. You don't even have to simplify it. Of course, what I want to do is simplify it a little bit because, that's going to take forever to do. Notice that this t right here and this t, we're actually going to cancel out one another, and that makes it a little bit easier. And so this also right here is in the denominator. And so my y is actually 1 divided by 2 square root of 4 plus t. And then in my x prime, I actually have a 4 divided by 4 plus t squared. This actually all combines together. This one actually comes to the very top, cancels a little bit with these. These guys here combine, and I got 4 plus t to the 3/2, all divided by 8. Okay, that's it. We're done. I took the derivative. Okay, let's do another one. So 10.2.007. We have an x is equal to t to the 9th plus 1. And I've got a y is equal to t to the 10th plus t. And they say find the equation of the tangent line at, so I'm going to say tangent line at t equals -1. So how do we do the tangent line stuff? What comes to mind? Well, a line equation is y minus y1 is equal to m times x minus x1, something like that. Well, this m is my slope, which is my derivative, dy dx. And so I need to find my derivative, and then I could plug it in basically. And so let's go and find that. My x prime is going to be 9t to the 8th. My y prime is going to be 10t to the 9th plus 1. And then I'm going to divide them, of course. So my dy dx, my y prime over x prime, is going to be 10t to the 9th divided by 9t to the 8th. And a whole lot of stuff cancels, of course. 10 over 9 times t, I guess. Is that what I got? Actually, I think I flipped them. No, that's fine. I'm looking at my notes here, and I flipped my notes around. Yeah. Interesting. Well, you actually get the same answer in the end, which is kind of weird, but I don't know why I have that in that way there. Oh, there's a +1. I forgot the +1, of course. Sorry. Okay. So yeah, this is not quite exactly it. You can't cancel anything. My bad. I'm going to step back. So yeah, I messed up a little bit. Sorry, I forgot the +1 right there. See? +1, forgot the +1. But on my notes, I actually flipped them, and yet I got the same answer. The reason why is because it actually makes just a -1. This is my slope, true, but they had given me that it's at -1, so what I'm going to have to do is plug in a -1 for both of these guys. And so I got basically -10 plus 1 is a -9. And down here I got the 8 power makes all the negatives cancel, make a plain old 9, and 9 over 9 makes a -1. So that's cool. That's, again, my slope. What I want to do is plug that in right here. That's a -1 right there. My problem now is that what is my y1, x1 stuff? So what I need to do is plug this -1 in there and find out what those actual values are going to be. So x at -1 is going to be -1 to the 9th power plus 1. It should be -1 plus 1 equals 0. And then y at -1 is going to be a -1 to the 10th power plus a -1, +1, and I got -1 equals 0 again, so 0, 0. So y minus 0 is equal to -1 times x minus 0. Simplify it down, and you basically just get this guy right here, which is good. That's your answer. That is the equation of the tangent line at t equals -1. Okay, 10, 2, 0, 4, 0. I have x is equal to 3 plus ln of t. I got y is equal to t squared plus 4. And they say that I need to find the equation of the tangent line at point 3, 5. So still the tangent line stuff. So of course, just like last time, what I need to do is find the derivative of these things. And so I'm going to find x prime, which would be 1 over t. Pretty simple there. Y prime is going to be a 2t, like that's it. So y prime over x prime. Of course, now I got 2t divided by 1 over t. And what happens is actually I get 2t squared. So that's my slope, that's my derivative, but my problem is I don't know what t is, right? What did they say t was? They didn't tell me. So I have to find out what my t value would be. In order to do that, I actually need to say that x is equal to 3 and that y is equal to 5 and solve for t, like with both of them, basically. Let's just start with the x. I think it's going to be pretty easy. 3 is equal to 3 plus ln of t. Solve for t. Well, 3 and 3 cancel one another, so I'm saying that the ln of t is definitely equal to 0. And the only way that happens is when t equals 1, like a positive 1. And you can go back and test it right here. If you plug in a 1 right here, you got 1 squared plus 4 makes a 5. And so you can see it's double checked good. And so I'm going to plug in the 1. 2 times the 1 squared is 2, and that's my slope. That's my m slope. There you go, m. And so going down, y minus y1, m, x minus x1. My y value, again, was a 5, if you remember back right here. That's x1, y1. And then I got a 2, and then x minus 3, and that's basically done. But if you want to simplify it down a little bit, it looks like this. And you're done. That's it. Next question, 102017. So I've got x is equal to e to the t. I've got y is equal to t e to the negative t. And they say find the first derivative and then find the second derivative. The first derivative is super easy because we've been already doing it. X prime, it's just going to be derivative of e to t is e to the t. Derivative of this guy is going to be a product rule, actually. So take the derivative of the first, leave the second one alone. Leave the first one alone. Derivative of the second makes a negative sign come down to the front. And so that's my derivative. So y prime over x prime should be, again, my dy dx, should be e to the negative t minus t e to the negative t, and then all divided by e to the t. Cool. Well, all of these e to the t's can actually be factored out. That's e to the negative t. Hold on. Be careful. That's e to the negative t right there that I can factor out. But this is a plain old e to the t here. What actually happens is that these don't cancel. They combine together. And so what you get is 1 minus t divided by e to the 2t. And that is your first derivative. So now they're wanting your second derivative. And this is the Leibniz notation, of course, d squared y dx squared. And so there's actually a reason why it's not a 2 right there. It's a 2 right here instead. If you go back, this is way calculus 1 kind of stuff. What we're actually doing is ddx of your y. So how many y's do you actually have? Just the 1. You see that? And so they just multiply them all through, of course, to make it look more pretty. That's the Leibniz notation. And that's good. Leibniz notation, good. But this is not going to be helping us because we have a lot of t's, and I need to be able to include t's somehow. And so let me rewrite this for you. What if I did ddt of dy dx divided by dx dt? Now, this is a strange thing, but this here, if you cancel out your dt's and all that stuff, it actually ends up being this guy. So this literally equals this thing right here. I just did a lot of fanciness to get to that. Again, this is more like a formula. I wouldn't say that you just know how to create this out of nothing, but could you go backwards and simplify it down? Yes. You can confirm with me? Yes. So this is what we got. The funny thing is that this guy right here is my dy dx, and so what I could do is take that and plug it in directly here, and then just rewrite this. Notice also right here, this dx dt thing, this is x prime. What I'm saying is this dt that I'm doing every time I'm saying find the derivative and take it in terms of t. So when I say x prime, or whenever I said dx, what I'm really saying is dx dt each time. And that's the more proper version, okay? And so I already have my x prime. I already have my first derivative, and so I'm saying find the derivative of 1 minus t over e to the 2t, and then divided by my x prime is just going to be an e to the t. Like, that's it. I just literally plugged it in. That was it. Well, I still need to find the derivative of this top one, and that's going to be a quotient rule, of course. So low d high minus high d low divided by the square of what's below. That should now be a 4. And then all that is still divided by this e to the t business. And so I made it a 4 because, again, it's squared, and so they combine together kind of thing. But these right here don't combine. They actually cancel one another, I think. No. Hold on. They do combine. Those guys combine, because this is just like this. It's a 1 there. These guys combine, but you can factor out an e to the 2t to the front. So let's do just a little bit of simplifying here. I got a -1, and here, distribute. I got another -1, and then I got a positive t, and then all divided by e to the 5t. Well, then this guy here, 2 and 5, should actually cancel to make a 3. So I got -2 plus a t, e to the 3t now in the bottom. I have a slightly different answer on my notes. I did this. I messed it up. You see it? I made one small mistake. This 2, I forgot to distribute to both of these guys. And so that's going to be 2, and that's going to be a 2, which makes this into a 3, and this a 2 right here. So there's my final answer. Stick around to the end. You know that I mess things up, and that's okay. It's okay to mess things up. Go back and say, why did I get it wrong? Oh, I forgot the 2. Common mistakes. Next question. So we got 10-2-0-2-1. It says find the points where the horizontal and vertical tangents exist. So the horizontal and vertical tangents. We'll explain what that means here in a second. I got x is equal to t cubed minus 3t. And I got y is equal to t squared minus 2. And they say go and find these guys. Well, the horizontal tangent is whenever you have a flat tangent line, something like that. And so what's your slope? Is 0. Slope equals 0. And so what that means is that your derivative, dy dx, is going to end up being a 0, which is a 0 in the top. I don't care what's in the bottom. And so my dy, my y prime, is 0. And so that's all I'm going to do. I'm going to say y prime is equal to 0. Y prime is super easy to do. Set it equal to 0, t equals 0. There we go. So that's my answer. Technically, is just t equals 2. Well, they actually want points, like xy points. And so we're going to have to use a comma and all that kind of stuff. Well, so what I'm going to do is take that 0 and plug it in. And I'm going to find out what we get. So 0 and 0 would obviously make a 0. And 0 minus 2 is going to be a -2. And so that's your final answer for that one. Now for vertical tangents, a vertical tangent, I'm just going to make up a sideways parabola, let's say. Vertical tangent looks like that. So what's my slope of a vertical tangent? Is undefined. What it means is that I have something divided by 0, which again, this is a dy dx. And so I'm saying my dx is equal to 0, my x prime is equal to 0. So I'm going to find my derivative of the x, which is going to be a 3t squared minus 3. I'm going to set it equal to 0. And so, of course, 3t squared minus 1 equals 0. The 3 doesn't matter. Move it over. Square root both sides. You get a plus and minus when you square root 1. And so that's my answer. at 2 different points we have this answer. And so what I have to do is plug in the -1 and the 1, 1, -1, plug them in, and see what we get. So here are my 2 answers. I can't remember exactly how WebAssign styles your answers, but when I plug them in, I get these guys here. I believe this is when I plugged in t equals 1. This is t equals -1. I'm not too concerned about plugging stuff in. That's easy stuff. Okay, next question. So I got 10, 2, 0, 3, 3. I got x is equal to 9t squared plus 8. And I got y is equal to t cubed minus 3. And it says, when is the slope equal to a half? Find out where that is. Okay, well, that means I'm going to find my derivative, dy dx, y prime over x prime. So I got 3t squared. Over here I've got 18t. That's it. Cancel a couple things, so we actually get 1 over 6t, I believe. Just looking here in my notes. Yep. Nope. Wait. T's in the top. T divided by 6. My bad. See, there's a 2 and there's a 1 right there. It's always good that I have my notes next to me. And they're saying this is equal to a half somehow. You could probably just look at it and get the answer, but multiply the 6 over, and t is equal to 3. So that's my answer, but I need to go and find out where those exist. So I plug in t equals 3 into both of these guys, and I get my point. So plugging in a 3 into all this, I actually get 89 and 24. So kind of a little strange numbers, but it works. Okay, 10, 2, 0, 3, 8. I've got x is equal to t squared minus 2t. I've got a y is equal to the square root of t. And they say find the area enclosed by the graph in the y-axis. I can't remember if they actually had a graph with this or not, but this is the shaded area. This is what they're looking for right here, and I need to find that area. So it starts here at 0, and then it crosses through, and blah, 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 blah. Well, I don't know exactly where it crosses through, but that's going to be really helpful to me. And how do I actually know that? It's whenever x is equal to 0. So notice here, x is equal to 0 all along the y-axis. So I've got t squared minus 2t is equal to 0, right? I could factor out a t, and so I've got t is equal to 0. And here I've got t equals 2. And so those are my 2 things here. Now, it says find the area, and this is not bad because I could just do an integral here of 0 to 2, right? 0 to 2 of something dt, I guess you can say. My point that I'm going to actually be making is that it's not quite this easy, but it's similar. It's similar in nature, but not exactly that way. What I want to do is eliminate the parameter into something that I can actually work with. And so what I'm going to have instead is this guy here turns into this. Plug it back in. So I got x is equal to y squared minus 2 times y squared. Something like that. But what is t equals 0 going to imply here? What about t equals 4? What's going on? Rather, I know that my x is going to be equal to 0 from here to here, but what's my y value? How high am I? And so if I plug in the t equals 2 right there, what you actually get is y equals, well, the square root of 2. And so I'm actually going to be finding the area going from 0 to square root of 2, blah, 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 dy. And you know, this actually is fitting because I actually already have y values ready and good to go. And so I got y to the 4th minus 2y squared dy, again from 0 to square root 2. Add 1 to the power, divide by the new power. Same thing on both sides. And I'm going to plug in the square root 2. 0 would cancel everything. Blah, blah, blah. And I got a negative 8 over 15 times the square root of 2. Of course, negatives are not going to be your area. It's a positive. Everyone knows that. Positive area. So why did I get a negative on my answer in particular? The reasoning being is that I probably had like my top minus bottom not right. I mean, notice right here, this is technically on the top and this is on the bottom. And so what I should have started with was an integral of all this with a negative sign right there. Or rather, I guess you could say integral of 0 minus all this stuff dy. Okay, so that's really the true way of doing it. I didn't do it, but that's why I got a negative. And it's okay, because we know area is positive. So you just make it positive. 10, 2, 0, 2, 6. X is equal to 8 plus 3t squared. Y is equal to 1 plus 2t cubed. I'm going from 0 to 5. Awesome. Find the exact value of the length of the curve. The length of the curve. So what they're talking about is arc length. And if you go back to the arc length formula, you got integral of the square root of 1 plus y prime squared dx, something like that. And that's really nifty. That's a good formula for rectangular mode. You would have to eliminate the parameter in order to do something like this. It's not really that easy. What they're really wanting to encourage is a new formula. It's very similar, but instead you're going to have x prime squared and y prime squared dt. Of course, I'm doing the Newtonian notation of just x prime, y prime. In reality, it's dx dt, dy dt, and all that kind of stuff. I'm shorthanding it a tiny bit. But this is actually a very similar formula to this. Actually, they are the same. If you look back and forth, my y primes are the same. But notice that my x prime here turned to a 1 because I'm going to say here, this is kind of like a funny little thing here. I'm going to have x. I'm going to say, hey, find the derivative of x. Find the derivative of x. Don't overthink it. It's a 1, isn't it? Boom, right there. It's a 1. So the point is that when you have a regular independent x variable, you take the derivative of that and it's just 1. So, all right. So let's do this formula thing and figure it out. I guess we're going to go from 0 to 5. Makes it pretty easy. My derivatives shouldn't be hard. I have a 6t. And then here I've got a 6t squared dt, again from 0 to 5. And I need to square that one too. I forgot to do that little square there. Very important. When you distribute your square stuff, you get a 36t squared plus 36t to the 4th dt. The 36 can actually factor out and get pulled out here. Makes that easy. You can actually also factor out a t squared. And so then I can say, well, that's just going to be a regular t on the outside. Okay. Again, 0 to 5, of course. So can I take the integral of this guy? Yes. Use substitution. du is 2t dt. It's going to cancel with this guy. You divide by the 2 and make a 3 in the front. Integral of the square root of u du. That's going to be u to the 3 halves divided by 3 halves. I'm going to make it actually the 3 halves, just like this. So this 3 halves right here actually is going to come up here. They're going to combine / cancel, and you just get a plain old 2 in the front, which makes it a little bit easier. Now, if we were just doing that, I'd say, well, plus c and we're done. But we're going from 0 to 5. And so I plug in the 5, plug in the 0. You actually get something when you do that. And I got 26 times the square root of 26 and then minus 1. I'm not going to show you all the details. It's pretty simple, straightforward, just plug it in kind of stuff. Okay, and another one, 10 to 0, 55. I've got x is equal to 5 sine squared of t, and then I've got 5 cosine squared of t, and I'm going from 0 to 5 pi. and they say find the exact value of the arc length and all that kind of stuff. Well, if you're looking right here at this format, it's actually interesting. This is not a circle. This is not a circle. It's a little different. And you'll see why I'm going to point this out to you here in a second. There are some problems on the homework where I think it would be much better for us to be able to have a graphing calculator available to be able to check this stuff, and it would make this problem go 50 times faster. But I have to not assume that. I'm going to go through it the long way here. So if you want to just skip to the end, it's not too bad. It's just confusing for a minute. But if you saw the graph, it would make more sense. So I need to find my derivative of both of these. This is technically just a 2 power, so the 2 is going to come to the front, making a 10, leave the inside alone, and then that's a 1 power, so then what's the derivative of the inside? Chain rule stuff, right? Well, the derivative of the inside actually makes a sine goes to cosine. And then same thing over here. The 2 is actually going to come to the front. I mean, I'm just reminding you that their notation is bad. This is what's going on. The 2 comes down. Now it's a 1 power, derivative of the inside, that kind of stuff, okay? Don't make that little 2 there get all more complicated than what he is. Derivative of cosine is actually going to be a negative sign. Okay, so my arc length is going to be integral, and they even give me some limits, which is nice. Square root of 10 sine cosine all squared, and then we got a negative 10 sine cosine, again, all squared, dt. So the negative here is obviously going to cancel. The 10s here make a 100 and a 100, which the square root of 100 is 10, but because you got 2 of them, you can actually make a 10 square root 2 come to the front. And so now what I got is 2, I guess I already put the 2 in there. The 2's already up there. 2, and I factored out, of the sine cosine squared. Well, the square root and the square should cancel one another. And so I just got integral of sine cosine. Turn the page. So in order to do this, what I did, and again, this is everything that I'm doing here, you're not going to have to do. Just, in fact, you kind of might have to do it, but what I'm going to get at is it's going to be different than what you're seeing. So I said, you know what, I remember this was a 2 sine cosine is actually sine of 2t. And so if I just take this guy and put a 2 right here, but divide it by 2, then I should be able to get that same format. This 2 can come out to the front. So then I've got, technically now, a 5 square root 2, and then I've got sine of the 2t dt. Well, integrating just the plain old sine is super easy. Sine's going to go to negative cosine, so negative 5 now, 2, and then I'm going to divide by the 2 because it's a u substitution kind of stuff there. Cosine of the 2t, and then from 0 to 5 pi. Okay. When you plug in the 5 pi and plug in the 0, what you actually get is 0. So there's your arc length at 0. Wah, wah, wah. That's not the right answer, obviously. So what you have to do now is understand the graph. So let's go back to the graph now. What it actually does, it's kind of a weird graph. It just goes back and forth, 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 like that. And what you're actually going to go back and forth 10 times. If you're going 0 to 5 pi, you actually go 10 times back and forth. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So how do we get this answer then? What I'm going to say instead of 0 to 5 pi, because again, where did you started here and you went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you're back where you started, and that's why you got a 0. So that doesn't help. If you check, like, how many miles did you travel in the car, it's not 0 miles that you traveled today. So we need to actually find out how many miles you traveled, even if it was back and forth. And so what I'm going to do is say, let's find one distance and then say times 10. okay? So I'm going to do that full distance, then times 10. So instead, let's make this pi over 2 because that's going to reach down here. This is 0. This is pi over 2. And so if I do just this, and then I say times 10, it should work out. And so what I actually got was my length of just the 1. So again, my integral from 0 to pi over 2 of everything we just had, blah, 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 is equal to 5 square root of 2. And that's nice, but I need 10 of those, so times 10, and you get 50 square root 2. And that's your final answer. So that's why the graph would be a little bit more important to see in this particular case. How would you know this? How would you know how to do this on an exam, let's say? Well, your final answer is 0. There's obviously a problem here. So I would have to make a graph, like a table, slowly work through it myself. And again, this is not necessarily on an exam, but that's my recommendation. So that's all I got. Thank you very much. Have a great day.